Data collection is one point. The other part, a second part, is measurement of our samples. Now what we do now, what we've done since the beginning, is to take our samples over to Heidelberg University. They're in Tiffin, Ohio, and they have a water quality laboratory. They're set up to do these measurements. They've been making measurements of water quality since at least for 20, maybe 30 years. And they've got these stations set up in the Maumee River and some other rivers draining into the Lake Erie. So this is old hat to them to measure this. And we would get them to measure the chemical quantities like phosphate. What's the phosphate in each sample, total phosphate? What's the nitrogen in each sample? What's the dissolved oxygen in each sample? That kind of thing. And we have 14 different parameters they were measuring, including chlorophyll A content and phycocyanin content, those two pigments I was talking about. As we progressed, we found out that the way they were doing the chlorophyll A and the phycocyanin measurements, called the extractive method, which a lot of people preferred because it was easier. You could take samples, you could freeze them. No, you filter them, then freeze the filters that have the cyanobacteria on them. And then at some later time at your leisure, you could measure the phycocyanin and chlorophyll A in them. Well, there are a lot of problems with that. The first problem is they've gotten rid of all the lake water. You're freezing a filter with cyanobacteria on it, but there's no lake water anymore. They've passed that on out. But that's the way it occurs when we look at it with a satellite. We're looking at these things in vivo, as they are in the water. So we went back to the way we had originally trained our phycocyanin algorithm and made in vivo measurements that Dr. Mike McKay and his graduate students do at Bowling Green State University in the Department of Biological Sciences. And they measure fluorescence of the cyanobacteria while they're still in the lake water. So that is what we're measuring, and that corresponds much better to our results than the extractive technique. So we still do that. That part now we do just at BGSU.